Okay, hopefully you watched that video that I linked above. And you're back here now, and this is kind of the Cliff's Notes version of that video, plus also getting you ready for doing examples. So if we talk about volumes by disks, first of all, if your axis of rotation is horizontal, then you will always draw your representative rectangle vertically, because for both, whether your axis of rotation is horizontal or vertical, it always goes perpendicular to your axis of rotation. Here's the axis of rotation, and there is your representative rectangle. And for a disk, the length of the representative rectangle is your radius of the disk. And remember, a radius is measured from the center of the circle to the outside. The center is always going to be your axis of rotation. So anytime you're drawing a radius or you're thinking about where a radius is, it should always be between the axis of rotation and then some other point. In this case, the further edge of the representative rectangle. Think about that when we get to washers, because washers can mess people up sometimes. But there's our radius, which in this case is going vertically. So you're always going to measure top minus bottom, and you'll just plug that in there into your formula. For a vertical axis of rotation, your representative rectangle will go horizontally. So this time your radius is going horizontally. So it's always right minus left. Remember, top minus bottom, right minus left, never the other way. Bottom minus top, that's not a thing. Don't do it. Left minus right, not a thing. Don't do it. But notice pi r squared, and in this case dx, or pi r squared, and in this case dy. If we look at washers, I wanted to draw the washer here because not my pictures aren't great, so it's hard to see it in the actual solid. But remember, a washer is formed when the rectangle doesn't touch the axis of rotation. But that means that your radii, the outer and the inner radius, neither one is the actual length of the rectangle. People always want to do that. It just seems natural to want to do that. But for a washer, the length of the rectangle is nowhere to be found in the formula. Instead, measuring between the axis of rotation and the far edge of the rectangle forms your outer radius, and then measuring between the axis of rotation and your near edge of the rectangle, that's your inner radius. Same thing for if it's a vertical axis of rotation, between the axis of rotation and the far edge is your outer radius, and then between the axis of rotation and the near edge of the rectangle, that's your inner radius. So when you are drawing your picture for your actual solid, then just keep that in mind. And same thing as before, if your representative rectangle is going vertically, then both radii are top minus bottom. And if your rectangle is going horizontally, then both radii are right minus left. But remember, the formula for the volume of a washer was pi, and then big R squared minus little r squared, and then h, which is our dx, or pi big R squared minus little r squared, and then h, which is our dy. And here, let me go ahead and actually put dx right here on this picture. And then once again, representative rectangles always perpendicular to the axis of rotation. Okay, next videos, now we're going to finally get into some examples. We'll work one out first, and then I'm going to encourage you to work the other ones out on your own, but the video will have the solutions worked out eventually. Okay,